Now let's just see some of the examples that are related with the nth term of an AP. So the very first example says find the 10th term of an arithmetic progression when the arithmetic progression is 2, 7, 12 and so goes on. So let's just find out the answer for this one. So first of all, as you can see in the arithmetic progression, that is 2, 7, 12 and so goes on. First of all, we can able to find out the common difference as nothing but, let us suppose if I am taking the common difference by taking the difference of the first two terms, so D would be nothing but A2 minus of A1. I am subtracting the second and the first term, so this would be 7 minus 2, which is nothing but is equal to 5. So this is nothing but 5, hence the common difference is 5. Again, we know that the first term over here is nothing but 2, so A is 2 and D is 5. So we know that A is nothing but 2 and D is nothing but 5. So using this information, we have to find out the 10th term. So if we are talking about the 10th term, it means N is actually representing 10. N is actually representing 10. So it means that if we have to find the 10th term, so it means N is nothing but is equal to 10. And we know that the general form or the nth term of an arithmetic progression actually represents, let us suppose if I'll write it over here, the general term is actually nothing but An is equal to A plus N minus 1 into D. And if we just wanted to find out the 10th term, so it would be nothing but A10, because N is nothing but 10. Let's just substitute N as 10 over here. This would be A plus 10 minus 1 into D. This would be A10, which is equal to A plus 9D, and hence we have to just substitute the value of A and D over here. So this would be nothing but A10 is equal to A. A is nothing but 2 plus 9, D is nothing but 5. So hence the answer is A10 is equal to 2 plus 45, which is nothing but 47. Hence the 10th term we will get is nothing but 47, and the answer for the very first question, that is, we just wanted to find out the 10th term for an arithmetic progression of such a kind. So this is nothing but 47 using the nth term of an AP. So this is all about how we can use the nth term of an AP, that is An, or the general term of an AP, in order to find out the answers for such type of questions. And now let's just see the next question. Let us suppose we have the next question as determine the AP whose third term is 5 and 7th is 9. So we have to find out the whole AP. So let's just start what is given to us. So according to the question, it is given to us that the third term is nothing but 5, and we know that we represent the third term as nothing but A3. So it is given to us that A3 is 5. Next, according to the question, it is given to us that the seventh term is nothing but 9. So it means A7 is given to us, which is nothing but is equal to 9. So let us suppose if I am taking them as the equation number 1 and equation number 2. So let us suppose if I'll start with the equation number 1. So as we have A3 is equal to 5, and if I'll remember, whenever we will have An, so we can represent it as A plus N minus 1 into D. This is our general formation. An is nothing but A plus N minus 1 into D, that is the nth term. So if I'm talking about A3, it means I'm substituting N is equal to 3 in this equation. So this would be nothing but A3, which is equal to A plus 3 minus 1 into D, which is nothing but A plus 2D. And we know that this value is given to us as nothing but 5. Hence, we have the equation as nothing but A plus 2D, which is equal to 5. Now, furthermore, if I'll substitute N is equal to 7 over here, we will get the answer as A7 is equal to A plus 7 minus 1 into D, which is nothing but is equal to A plus 6D. And we know that A plus 6D is nothing but is equal to 9. So now let us suppose if I am taking this as nothing but the equation number 3 and this as equation number 4, and I'm now solving the equation number 3 and 4 all together. And we know how we can solve such type of the linear equation in two variables. So let us suppose if I am using the method of elimination over here. So this is nothing but A plus 6D, which is equal to 9. After the elimination method, A and A would get cancelled, minus of 4D, which is equal to minus of 4, negative get cancelled, D would be nothing but is equal to 1. So we are getting common difference as 1. Let us suppose if I substitute this D is equal to 1 in the equation number 3rd. So in equation number 3rd, A plus 2 into D is 1, it is equal to 5. So A is nothing but is equal to 5 minus 2, which is equal to 3. Hence we are getting A as nothing but is equal to 3. So if A is 3, common difference is 1. Let's just find out the values. So if A1 we are getting is 3, then A2 would be nothing but A1 plus of D, which is nothing but 3 plus of 1, which is equal to 4. Further, A3 will be is equal to A2 plus of D, which is nothing but 4 plus 1, which is equal to 5, and so goes on. It means the arithmetic progression would be 3, 4, 5, 6, 7, 8, and so goes on, because the common difference we are getting is nothing but 1. Hence, the arithmetic progression which is related with the example number 2 is nothing but 3, 4, 5, 6, 7, 8, and so goes on. So this is how you can able to find out the arithmetic progression whenever the two terms are given to you.